In this quick tip, we talk about how to solve right triangles when we're given one angle and one side. Now I have two examples here. In one case, the given side is a leg and the other side it's an hypotenuse. That's really the only material difference between these two. So let's jump in and solve the first one. In the past, when we had two sides, we could use the two sides in the Pythagorean theorem in order to compute the missing side. We can't in this case because we don't have two sides to work with. So that means we have to begin with the trig function. It has to involve this known angle 32 degrees, and it has to involve this known side of 6. So let's do this one. The sine of 32 degrees is the known side, 6, over the length of the hypotenuse. Let's give that a name. We'll call that C. Then we can multiply each side by C. That'll put the C up here. And we can divide each side by sine of 32, which will put the sine of 32 degrees down here. And now, fortunately, everything on the right-hand side is a number. So we can do that with our calculator. If we round that calculator value, we have the missing side C is 11.3225. All right, now we know two of the three sides, and we are missing one angle and one side. The missing angle can be computed very easily. Let's call that alpha. Alpha is well, we know that 90 degrees of the 180 are used up here, so we have 90 between those two. Of those 90 that are left over after you take into account the right angle, we've used up 32. So 58 remain, and we have this angle here. Now we're only missing one side. We have options here. We could use the Pythagorean theorem. We could use a trigonometric function. Why don't we do the latter? I'm going to call this side B, and then the cosine of 32 degrees is equal to B over 11.3225. And this step right here is why we are keeping so many decimals. If this had been rounded off, this would be an inaccurate calculation, and we really would have to avoid using this calculated side in further steps. But in this case, we kept a lot of decimals, so we just multiply through by that value, and we have B is equal to 11.3225 times the cosine of 32 degrees. And we get that with our calculator. And we have about 9.6020. Okay, we have all three sides now, and we have all three angles. So that triangle is solved. Let's move on to this one. The process is very similar. Let's call this side B. And we're going to work with that angle 75. So the sine of 75 degrees is B over 14, multiplying through by the 14. And we get a decimal approximation. $13.5230 with rounding. All right, this angle here, we've used up 90 of the 180 in the right angle. So this and this have to sum to 90, and that means that 15 are left over here. We have all three angles now. And we have two of the three sides. So how about if we do the sine again? Sine 15 degrees is equal to this missing side, the length of the missing side, A, over the length of the hypotenuse 14, and once again we multiply through by the 14, and this can be computed with our calculator with rounding. We have 3.6235. All right, we have then all three sides and all three angles. Both of these triangles have been solved.